Hello, this is Mr. Collier. Today we're solving some more trig equations, some with GDC and some using identities. Okay, so let's look at number 1b. We can use an identity here to simplify and you get a quadratic and all that stuff, but we're going to do this one with a GDC. So let's make sure you're in radian mode first of all. Let's go to graph it, and I'm going to put 4 here instead of 10. We'll give you a horizontal line at 4, and then we'll just type in. Now you can't type in secant on your calculator, so you have to do make a fraction, do 1 divided by cosine, or cosine squared, and we need that to be in brackets, so let's do cosine x and squared. Okay, that's the same as secant squared. Then minus 2 tan x. Okay, then we want to maybe consider, oops, let me click OK. Let's make sure we do shift plot and set it up nicely. The interval is negative pi to pi, so you can type in literally that, but you want to see negative pi, so negative pi is 3. Let's go negative 4. Oops. Negative 4 to 4, then we'll see negative pi and pi. We want it to go up to 4, so let's do negative 1 to 5. Yeah, there we go. Now we should be able to see it perfectly. Okay, that's interesting. We can see there's 1, 2, 3, 4, 5 answers. Okay, so simply click and get, oops, let's go to get this answer. We click there and we go to intersection and we get the answer, and that is negative 0.785. So x equals negative 0.785. There's 5 answers, so you can list them all. To show your work, you could do a little bit of a sketch and show the line intersecting at 5 points. Okay, so you can get all 5 answers the same way. Just if you want this answer over here, click here, then go to function, intersection, and you get that point as well. Anyway, let's move on to the next question. Let's do number 3 here. Now we've got cosine theta, cosine 3 theta, and cosine 5 theta. So again, we can use the sum or the compound angle identity formula in your formula booklet. Okay, so we can write cosine as cosine 2 theta plus 3 theta. Okay, we can write cosine, we'll keep cosine 3 theta the same. And then you can write this one as cosine 3 theta minus 2 theta. What that does is gives everything in terms of 2 theta and 3 theta instead of 3 different arguments for cosine, right? So using the formula, you got cosine 3 theta sine 3 theta, sorry, 2 theta. Okay, and then this is a minus, so this becomes plus. Sorry, that's cosine right there. The formula goes cosine, cosine, sine, sine. So that's cosine. So we have sine 3 theta, cosine 2 theta. Okay, then this is just this one, cosine 3 theta. And the last one here, we got cosine 2 theta, cosine 3 theta minus sine 2 theta sine 3 theta, right? Equals 0. So what happens after that then? We have, actually these two cancel because one's plus and one's minus, right? So that worked out nicely. And then all the other ones have a 3 theta on it, so you can factor out cosine 3 theta. Okay, factor out cosine 3 theta, and we got cosine 2 theta plus 1 plus cosine 2 theta equals 0. So from that we get cosine 3 theta equals 0. And from this we get 2 cosine 2 theta equals negative 1. Cosine 2 theta equals negative half. So we got two separate equations we can solve. They're gonna have two different ranges. So this is 3 theta, so we have to change the range to 3 theta. So that's going to be up to 6 pi. And for this one here, we've got 2 theta, so that we need to look at all the answers up to 4 pi. Okay, cosine is 0 here at pi over 2 and at 3 pi over 2. So 3 theta equals pi over 2, 3 pi over 2, 5 pi over 2, we're going all the way up to 6 pi, 7 pi over 2, 9 pi over 2 is 4.5 pi, right? 11 pi over 2 is 5.5 pi, and that's the last one. So theta equals pi over 6, pi over 2, we're dividing everything by 3, right? 5 pi over 6, 7 pi over 6, dividing by 3, we get 3 pi over 4, or over 2, I mean. And this is 11 pi over 6. Okay, and then from this one here, cosine is negative half. So in the triangle 1, 2, root 3, cosine is negative half. That means it has to be this angle, which is pi over 3. That one's pi over 6. This one's pi over 3. So 2 theta. Now cosine is negative here, starting with here, right? So if that's an angle pi over 3, then this angle is pi over 2 pi over 3. So 2 theta equals 2 pi over 3. Then this angle here is 4 pi over 3. And we're going to have two more answers, because this pi over 3 you can go around 2 pi radians, so you can add 2 pi to both these answers, right? So 2 pi is the same as 6 pi over 3. So that becomes 8 pi over 3. And this one's 10 pi over 3. So dividing everything by 2, you get pi over 3, 2 pi over 3, 6 pi over 3, which is just, no, that's not 6, that's 4 pi over 3, and 5 pi over 3. Double check to see if there's an overlap, and there isn't. So these are all the answers. Okay, next we're going to do this one. You might think of using identity, but in this case it's going to be more complicated using identity. If you got just sine equals sine, or cosine equals cosine, tan equals tan, if you got different argument in here, like a 4x and an x, you can solve this differently without using identity. You can take a look at the unit circle to help you out. Let's look at what... okay, so here for sine, these opposite quadrants have the same sign, right? Because they're both positive here, right? So if you want to find out when sine x equals 4x, for instance, let's say this is x, and let's say 4 times x lands over here. Okay, and they happen to be, equal at this point. So we want to find that the x value such that that's true. So that angle right here, the reference angle, is pi minus x. Okay, that reference angle is pi minus x. So basically that means you have 4x equals pi minus x. So you can solve that equation. 5x equals pi, and x equals pi over 5. So that's one answer. If you check it, you can check it pretty easily. You get sine 4 pi over 5 and sine pi over 5, and those have the same sign because they both make the same angle with the x-axis, right? But it could also be the case that the angle is like it's gone around this much, then all the way around again. So and back at this point, right? So it could be the case that you have 4x equals 3 pi minus x. And then you get 5x equals 3 pi, x equals 3 pi over 5. Okay, so you get x equals 3 pi over 5. And you can substitute that in, you get the same thing for both of them, right? We could do that again. You could say 4x equals 5 pi minus x, right? Was 5x equals 5 pi. So x equals pi, and that is included in our range, so that is another answer. But if you do it, so basically you get pi over 5, 3 pi over 5, pi, you keep going with that pattern, 7 pi over 5, but 7 pi over 5 is too big, right? Now I start with the more complicated part first, because it could also be the case that that this is x, and then 4x ends up back here, right? Well, that's probably not very accurate drawing, but if you got like an x over here, for instance, maybe the 4x ends up back at exactly the same spot, so they have the same exact sign value, right? So we would have 4x equals x plus 2 pi. So you get 3x equals 2 pi, and x equals 2 pi over 3, right? Could also be the case that you get 4x equals x plus 4 pi. Then you get 3x equals 4 pi, and you get x equals 4 pi over 3. That's too big, it's outside of our range, so we actually have only one extra answer, so we have 4 answers in total.